Hello everyone. I'm going to answer another stoichiometrical problem, the one that you can see on the screen. So the first thing that you need to do every time you have a problem is to make sure the equation is already balanced. Notice we have one potassium here and one potassium there on the product. So potassium is fine. One chlorine, chlorine is fine. But then we have oxygen here. We have two oxygen. Actually, it should be the correct equation should be KCl, like a potassium chloride, uh, plus oxygen subscript forming potassium chlorate. That will be the right formula. So we have three oxygen on the right and two on the left. The only way we can make equal, so two oxygen here and three oxygen there, is finding a minimum common multiple that will be multiplying this one by three. And that will give me six oxygen. And then if I multiply this by three, I mean this one by two and this one by three, then I can have six oxygen. So I'm going to place a three here. That will make six oxygen, and a two there, and that will make six oxygen. By doing so, and now modifying the number of potassium and chlorine. So I have to place a 2 here, and then I will have 2 potassium on the left, 2 potassium on the right, 2 chlorine on the left, 2 chlorine on the right, 6 oxygen on the left, 6 oxygen on the right. And that's the first thing you need to do every time you are doing any stoichiometric calculation, because without balancing, there is no way you can get a proper answer at the end. So let's then continue. They say on the reaction we have 64 point gram. By the way, I changed the numbers. This is a similar that you have on the quiz, but I changed the numbers, so don't. I the answer I will get probably will not match your answer, but just but it's exactly the same problem. So we have 54 gram of potassium chloride, 54.9 gram, zero point 0.9 gram, and they say are reacted with excess of oxygen. So we don't have limiting reactant here because there is an excess of oxygen. So we have plenty of oxygen to react. So the only substance that we need to be doing the calculation is the potassium chloride to produce potassium chlorate according to this reaction. If 60.1 gram are produced, they're referring to the only product is potassium chloride are produced mean the product. What is the percent yield? Percent yield will be equal to actual yield, which is given already. The actual yield is this one over theoretical one, which is not given. We need to calculate times 100. The actual is already given. This is the real amount that you get when the reaction takes place, 67.1 gram. And we need to find the theoretical. How? Finding the mass of potassium chlorate being produced on this reaction. How can we solve for that? Well, the easier way will be converting this mass to mole, because I know that 2 mole of potassium chloride will produce 2 mole of potassium chlorate, and the ratio is just 1 to 1. So if I find the mole of this, I already get the answer in mole, of course, of potassium perchlorate, and then convert into gram. So let me find the molar mass of potassium chloride. I have to check the periodic table, and somewhere around here I had the periodic table. I need to get that, and that will be potassium chloride. The molar mass of potassium chloride will be the following: 1 potassium, 1 chlorine. I go 7455. So let me convert this gram to mole. Number of mole of potassium chloride will be equal mass of potassium chloride over the molar mass of potassium chloride. Then that will be the mass given here is 54.9 grams over the molar mass of potassium chloride that I just did the calculation, 74.55 gram mole. And dividing that, I'm going to grab my calculator. 54.9 divide 74.55, I go the following mole: 0.734, I think 6 mole. That will be the amount in mole that I have here, and that will be the same because it's 2 to 2 is the same amount that you get here on the reactant will be on the product. How do I need that? How do I know that? Because um, for every 2 mole of this, you get the same amount of mole of the product. For every 0.736, you get the same number of mole on the product. It's the same number of mole. Just in case you don't remember how to calculate this number here, because you probably say, well, where did he get that number from? Okay, molar mass of potassium chloride is one atom of potassium times the atomic mass of potassium plus one time the atomic mass of chlorine. And that will be, and now I have to use the periodic table. One time molar mass of potassium in my periodic table here, 39.10, plus one time molar mass of atomic mass of chlorine is 35.45. When you multiply and add all together, you will get the 74.55, and the units are gram mole. This is just extra, okay? Because maybe you don't remember how to do that. And well, we had the mole of the product, and the reason I'm doing this is I need a theoretical yield. How can I find out the mass of potassium chloride? That's the one that I need now. Well, remember the same formula we use here. We say number of mole of potassium chlorate, sorry, will be equal mass of potassium chlorate over the molar mass of potassium chlorate. If we need to solve for this, mass of potassium chlorate, I'm going to scroll a little bit to the left so I have more room here, equal number of mole of potassium chlorate times the molar mass of potassium chlorate. Number of mole is the same, this one here, because it's we already calculate that 0.736 mole, and the molar mass, you need to go back to the periodic table and do the same procedure that we did before with the potassium chloride, and I go the following value after checking the periodic table and the atomic mass, and that will be mole and mole cancel out, and I need to multiply now that number 0.736 times 1.22.55. Oops, I need to recalculate that. 1 point, oh, okay, let's do that. 0.736 times 122.55. I just mistyped the number on the calculator, and that's why I go 90.19 gram. We can round to 2 because we are using 366 here, so you can do the following: 90.2 gram, and that will be your theoretical yield, and then multiply by 100, and that will be the final answer, dividing 67.1 divide 90.2, and I go after multiplying by 100, 74.4, and just round it, and that will be the percent yield of this reaction. Again, you need to find the relationship between the only reactant because the oxygen is in excess. It doesn't count for any calculation, and that will be the same of the product. Once you have the mole of the product, convert to mass by multiplying the number of mole times the molar mass. Remember, for finding this number, you need to go to the periodic table and adding one time the atomic mass of chlorine, one time the atomic mass of, potassium chlorine, and three times oxygen. And that was 122.55. And then dividing this, doing this, because this is the actual, over theoretical time 100 will give you the answer. So that's my answer for the problem. Thank you for watching. Hopefully this one helped you to do the one on the quiz.